All right, so now we're going to talk about the different number sets that we have used and looked at over the course of this course and just in all of the math courses that you've taken up until now, and probably talk about some number sets that you maybe have never heard about before, but we just want to get a handle on what different sets of numbers actually look like. So when you were little, when you were a really little kid and you were learning how to count, you started with numbers that were called the natural numbers. Natural numbers. Your parents or whoever taught you how to count started you off at number 1. So the natural numbers start at 1, then go to 2, then 3, and so on. Okay, so natural numbers start at 1 and count up. They're only positive, they don't include 0. When you got a little bit older, you started including the concept of 0 and recognizing what 0 actually meant, that 0 is our placeholder for nothing and that 0 carries no weight. When you include 0 into the natural numbers, those numbers are called whole numbers. So whole numbers are kind of what we stick with in the math world for much of elementary school and even a lot of middle school. Whole numbers are what we work with quite a bit. Then we get into things called integers, and we understood this concept of negatives. So when we talk about integers are still thinking of whole numbers, but they also include whole numbers opposites. So integers count all the way down from negative infinity to -3, -2, -1. They include 0, count 1, 2, 3, and all the way up to positive infinity. And I should say that natural and whole numbers go up to positive infinity as well. So when we go from natural numbers and whole numbers into integers, now we're thinking of this concept of negatives. And we think about down from negative infinity all the way up to 0 and then all the way up to positive infinity. Outside of the integers are within a number system called the rationals. Rational numbers. And rational numbers, if you think of the first 5 letters, are ratios, or in other words, fractions and decimals. So when we think of rational numbers, we think of numbers like -3/2, positive 10.6. Even numbers like 0.3 repeating. Anything that has a terminating or repeating decimal is a rational number. Anything that can be written as a fraction or as a ratio. 3/2, 10/6, 100/12. Any number that's written as a fraction is considered rational. And those give us terminating and repeating decimals. Those rational numbers are in conflict or in juxtaposition with the irrational numbers. Irrational numbers will be this little circle that's down here by itself. Irrationals are numbers that don't end and don't repeat. Don't end and don't repeat. Possibly the most common irrational number that we think about is pi. We've all learned that pi is one of those decimals that is non-terminating, non-repeating, and it's become a popular competition to memorize see how many digits of pi you can memorize. Some other common irrational numbers are things like the square root of 2. Really, the square root of any number that's not a perfect squares are those numbers 1, 4, 9, 16, anything that's an integer times itself gives you a perfect square. Anything that's the square root of a non-perfect square, like the square root of 2, square root of 3, square root of 10, 2, 3, and 10 are not perfect squares. So those are going to give you irrational numbers. They're going to be decimals that go on and on and on and on and on. They never end, they never repeat. So those are irrationals. Now, all of these number systems that we've just looked at are part of the number system that we call real numbers. Real numbers. Okay, so the real number system is the number system that you are going to spend most of your mathematical life or most of your mathematical courses and coursework will be in real numbers. Now, occasionally we get into numbers that are called imaginary, and imaginary numbers are kind of funny. Imaginary numbers have something that we call I. Okay, and that's what happens. Now, if you think back to the quadratic unit in Unit 5, we talked a little bit about how when we take the square root of a negative number, there is no real solution. Now, I made a big deal about that being no real solution. That didn't mean that there was no solution at all. It just meant that there was no real solution. I comes from taking the square root of -1. When you take the square root of a negative number, you get I. That's where this imaginary number set comes from. So like for example, the square root of -16 gives me 4I because the square root of 16 is 4 and the square root of -1 is I. So these right here are considered imaginary numbers. That's a concept that we probably haven't talked about before. That's probably a little bit new for you. And then the very last number set, the biggest number set that there is, encompasses both real and imaginary, and that's what we call complex numbers. And they're complex for a reason because they have both a real and imaginary component. So both a real and an imaginary part. So an example of a complex number would be like 6 plus 2i, or 3i minus 8, because they have a component of that 6, which is a real number, and they have the 2i component, which is an imaginary number, thus making them complex. So complex have both a real and an imaginary part. And complex numbers are the biggest number system that we have. But like I said, we are typically going to be spending a lot of our time in this real number category. When you get into Algebra 2 and pre-calc, you'll start looking into some more with imaginary numbers, but most of the time we're going to be operating with reals. So that's just a little glimpse of our number systems and what they look like and how they're all encompassed within each other.